we are now going to look at the types of muscle fibers and the function that they have. First, the spawn examples for them. So this can be applied to the gifted and talented students in the gifted and talented group. So first, slow oxidative muscle fibers. So they last for a very long time. So that would be most suitable for endurance athletes, as seen here. So, for example, endurance running, like marathon running, half marathon running, 10K running, stuff like that, which is done over a long period of time. So students from this gifted and talented group would rely greatly on their slow oxidative muscle fibers if they were endurance athletes. For FOG muscle fiber types, that would be suited for students like middle distance runners in the gifted and talented group. So, for example, the 800 meter is a good example of this, as that requires the use of the FOG muscle fiber type, probably the greatest for it. This is because the 800 can be classed as a sprint, but it's just not quite a sprint. So it wouldn't use it would use the fast glycolytic muscle fibers, but obviously they would tire first. So then the fast oxidative glycolytic muscle fibers would be relied on to maintain performance throughout that race to get the quickest possible time for it. Finally, fast glycolytic muscle fibers, that is used in many sports, and my example here is of a javelin thrower in the gifted and talented group, as throwing that javelin is a very explosive movement, and so would require the fast glycolytic muscle fibers, as they are the most powerful muscle fibers, to throw that javelin the furthest possible distance. Now, the primary role of a slow oxidative muscle fiber is for first posture, actually, as the postural muscles are constantly partially contracting, so obviously they would need to work for a long period of time as they're constantly maintaining posture for you, and so would work aerobically, and therefore makes the most sense for slow oxidative muscle fibers to be used, as they work with oxygen, and the slow oxidative muscle fibers can work for the longest period of time without fatigue. FOG muscle fibers are used, their primary role is used in medium intensity and medium distance. So would be slightly longer than a fast glycolytic muscle fiber. So longer than a sprint, as the fast glycolytic muscle fibers would be used to produce the greatest and most powerful movements for it. But if it's longer than a sprint, then they would fatigue, and so the fast oxidative glycolytic muscle fibers would be used for that middle intensity and distance, as either the fast glycolytic would fatigue or the slow oxidative wouldn't produce a good enough performance or maximum performance. For a fast glycolytic muscle fiber, its primary role is for explosive movements, high intensity and low distance. So, for example, the javelin, that is a very explosive movement. So, obviously, the fast glycolytic muscle fibers would be used, and the high intensity, because the fast glycolytic muscle fibers are the most powerful muscle fibers. That means that they would be used so it can produce the most power or the most speed, so the performance would be maximized and would be the best possible performance they could have. The contraction speed of a slow oxidative muscle fiber would be relatively slow, to be fair, as they are working for a long period of time at constant, well, not constant, but at a constant speed. So as it's also working aerobically, the contraction speed of a slow oxidative muscle fiber would be quite slow compared to the other two. And a fog muscle fiber would then be the next slowest, as it will work faster than a slow oxidative muscle fiber, but isn't as big or as powerful as a fast glycolytic muscle fiber, and can last longer than a fast glycolytic muscle fiber. So the contraction speed wouldn't be as quick as a fast glycolytic muscle fiber, and well, therefore the fast glycolytic muscle fiber has the fastest contraction speed, as it is providing that most energy in the shortest period of time. So it would use most energy possible in that time. Now, the force contraction of a slow oxidative muscle fiber would be quite small, as it's working over a long period of time, so it won't be able to use strong bursts of energy to create a large force. So the force contraction of a slow oxidative muscle fiber would be quite low, whereas in a fast oxidative glycolytic muscle fiber, the force of the contraction would be greater, as it's over a shorter period of time it's working for. So it's able to produce a higher force. The fast glycolytic muscle fiber then produces the highest force of contraction, as it's working for the shortest distance at the highest intensity, so needs to have the highest force and contraction. And it also has the largest diameter from the structure. We saw it had the largest diameter, therefore it can then produce the highest force and contraction from that. Slow oxidative muscle fibers would have a greater resistance to fatigue, as they can last for a much longer period of time than the other two muscle fibers, as the slow oxidative muscle fibers can last for many hours, as it's working aerobically, so works with the oxygen, so it can work for a long period of time, so it's very resistant to fatigue. The fast oxidative glycolytic muscle fibers can work for a few minutes, so about half an hour maximum. So there's a relatively good resistance to fatigue, but not the best. So worse than fast glycolytic, but better than slow oxidative muscle fibers, as they are working both aerobically and anaerobically. So that anaerobic respiration would eventually build up that lactic acid, which would make the performer stop and fatigue. However, fast glycolytic muscle fibers have the lowest resistance to fatigue, as they are purely working anaerobically, so would produce a lot of that lactic acid quickly, so would fatigue very quickly, and therefore has a very low resistance to fatigue. The aerobic capacity of a slow oxidative muscle fiber is very high, as we saw in the structures of muscle fibers. Slow oxidative muscle fibers have a very high amount of aerobic enzymes. So that means that aerobic respiration can occur at a higher rate, as there's a lot of aerobic enzymes. That means the aerobic capacity of a slow oxidative muscle fiber would be very high, and is in fact the highest out of all three. The fog muscle fiber types would have still a relatively high, so about a medium amount of aerobic capacity, as they've still got a medium amount of aerobic enzymes, so can work aerobically relatively well, but not as well as the slow oxidative muscle fibers. The fast glycolytic muscle fibers had very low aerobic enzymes, so would have a very poor and low aerobic capacity, as it can't work aerobically very well with the little amount of aerobic enzymes. This is then linked to the anaerobic capacity. So the slow oxidative muscle fibers, as it had a low amount of anaerobic enzymes, that means therefore there'd be a low anaerobic capacity, as it can't work anaerobically for very long, or it doesn't work anaerobically in fact, so has a very poor anaerobic capacity. The fog muscle fiber types had a high amount of anaerobic enzymes, so therefore can work at has a high anaerobic capacity, as it can work anaerobically quite efficiently, but would be slightly less than the fast glycolytic muscle fibers, which had the most anaerobic enzymes, as it purely works anaerobically, so has by far the highest anaerobic capacity, therefore, as is working anaerobically. Finally, the recruitment order of this is first, well, the brain first recruits the fast glycolytic muscle fibers, as they would work for the shortest amount of time, and once they fatigue, then the fast oxidative glycolytic muscle fibers are recruited, as they have the second most powerful movements, and so can work, and also works for the second shortest period of time. And then finally, the slow oxidative muscle fibers are recruited third, as they are have the lowest force of contraction, so would be the weakest out of all three muscle fibers. That is going to end the video, and next video we will look at muscle contraction and the process of that.